Okay, so like I said before, today we're going to be talking about evidence that supports the theory of continental drift. The theory is basically stating that a long time ago, the continents were all joined together in a supercontinent, and over time, they drifted apart to their present locations. This theory was proposed by Alfred Wegener, and it is because they found fossil evidence of various species across several continents. And these continents are now oceans apart from each other. So he concluded the idea that they had to have been joined together in some way for those fossils to have been found grouped together. Later came along the theory of plate tectonics, which suggests that the plates in the lithosphere are what move our continents apart. Okay? So what you see on this first page is the different types of species that they found. Okay, so for example, we have this Cynogathus. I don't know how to pronounce it, but I'm going to try. And it's a dog-shaped mammal-like meat-eating reptile. Okay, and I think that's a pretty accurate description. Well, they found fossils of this species in Africa and South America. And then you have this plant, okay, and it's a seed fern with tongue-shaped leaves. This one's probably the more remarkable one because they found fossils of this plant in Africa, India, South America, Antarctica, and Australia. So that is 5 different continents. One of them is a continent that is pretty much 100% ice. And then we have this naked mole rat dinosaur looking thing. I'm not going to try and pronounce its name. But it's a plant-eating dinosaur with short legs and a barrel-shaped body. And they found fossils of this animal species in Africa, India, and Antarctica. Then we have the Mesosaurus, which I do know how to pronounce because one of Oliver's favorite dinosaurs is a Mosasaurus, and they're very similar. But it's a freshwater crocodile-shaped reptile, approximately 1 meter long, which doesn't sound very big to me. I would have thought it would have been bigger. But they found fossils of this Mesosaurus in Africa and South America. And then they found a lot of rock evidence, which is similar matching rock strata sequences of the Appalachian in the United States and the Caledonian Norway mountains. And they found these this rock evidence in the United States, Greenland, Norway, United Kingdom, and Africa. So there were several places where they found this rock evidence. Something else that's interesting is that scientists are able to determine the age of these fossils, and a lot of the fossil species were from the same time period. So each one of these species has a colored dot next to it. And what I've done with that is I have gone to this current, most up-to-date map of the world today. Okay, so this is like a flattened version of our globe. And I took those colored dots and I highlighted the areas where these species were found as best I could in Google Slides. So this red is the rock evidence. Okay, so they found that rock evidence in North America, Greenland, Europe, and Africa. And I mean, they found it in specific locations of each one of these places. So I couldn't just put that red dot over here on the west side of North America. They found it near the Appalachian Mountains, so up in this upper northeast corner of the North American continent, pretty much all of Greenland, this northwestern area of Europe, and the northwestern area of Africa. And that is the red dot, so that's our rock evidence. The Mesosaurus was found in the southern part of South America and the southern part of Africa, so in this little area here, South America and Africa. And then you got to realize you have the whole Atlantic Ocean in between them. The next one was the mole rat dinosaur, because I don't know how to say that name, and that's like a brownish color. And if you look on my map, a big chunk of Africa, in this middle part of Africa, the middle upper part of India, and then over here in Antarctica. So it's hard for me to imagine as a puzzle how I'm going to fit India over here and Antarctica up. They somehow these little brown sections connect. Okay, and then the next one is that plant. Okay, and the plant is this green, and so they found it in this part of South America, this part of Africa, the southern tip of India, all across the continent of Antarctica, and then in a section of Australia as well. Then the last one, I believe, is this yellowish color. And the yellowish color is the Cynagathus, this dog-shaped mammal. And so they found fossils of this species all the way across South America and a big chunk of Africa as well. So you can see how these same species, the fossils of each of these species was found all over the world. And so what we're going to do is we're going to demonstrate, we're basically going to virtually connect and show the relationship of those fossils in a Pangea time. So what I did is I just copied and pasted each one of these red dots representing rock evidence, which means they found similar types of rock and rock patterns and rock age in all 4 of these locations. And I pasted them on this map of Pangea so that you guys can see that when they're pasted in the same location as they were on the present day example, how they were bunched together. And because of that fossil evidence, that's how they were able to piece these continents, North America, Greenland, which is not a continent, but Greenland, Europe, and Africa, how they were able to kind of puzzle those together based off of that rock evidence. And so we're going to do another example with the dog mammal-like animal. Okay, and so what you can see with the dog-shaped mammal, this Cynagathus, is that South America fits almost perfectly within that curvature of Africa, and based off of where they found that fossil evidence of that species, it lines up almost perfectly. You can see that there is a lot of overlap in where they found those 2 species, and then with the shape, the fact that South America and Africa fit very puzzle-like draws a lot of support for the theory of continental drift. The next species that we're going to do is going to be the plant species that I cannot pronounce. So when we look at this, after we combined all of these green shapes together in a similar location, we can see how that fossil species, how when connected to Pangea, why it was found across 5 different continents. And what made this especially interesting, as you can, for plate tectonics, is you can see how the continents or the land formations like India and Australia have turned and how their shape has changed over time compared to a more present day example. So once we added the last 2 fossil species, you were able to see how they formulated the theory of Pangea and how they came to the conclusion that all the continents were one supercontinent based off of this fossil evidence and the shape of some of our continents like South America and Africa. You can kind of see the fossil trail between each of these species over the course of all of these different continents. For example, this green was representing the plant fossil, and they found it across 5 continents. This animal species was found across 3 that are now whole oceans apart from each other. So using fossil evidence, Alfred Wegener was able to develop the theory of continental drift, that we started as a supercontinent called Pangea, and over the course of time drifted apart to where we are today.